It's Andre from High Performance Academy here. Welcome along to another one of our webinars. Now, today we're going to be talking about setting the correct dwell time for your ignition system. It's a question we get asked about a lot. I know there is a lot of confusion about this, and definitely if you can get it wrong, if you do get it wrong, you're going to have some problems at best with an ignition misfire, and at worst you're probably going to end up destroying your ignition system, or at least your coil. So we'll find out about that shortly. Before we get started though, just wanted to give you a bit of an update on what's been happening here. Last week I was talking about our white Toyota 86. We've got the engine back together. This is our Ghetto Build, as we have affectionately nicknamed it, where we've only changed over the set of factory rods for a set of Brian Crowett rods. Still running the factory pistons. We've got a set of ARP head studs and a set of HKS head gaskets in there. It was a reasonably frantic opportunity to try and get this back together, as we did have a race meeting over the weekend, and unfortunately the race car gods did not shine on us in this instance. I'll just head across to my laptop screen, and we have got the engine sitting in the car, which in itself was actually a pretty big challenge. The reason being that the whole car had been apart, and you can just barely see it right here, and there's another one over here. We had the entire engine bay stripped out because we got a roll cage installed, and as part of this the roll cage actually extends forward to the front strut towers. So to try and get this looking as nice as we could get it, we took the opportunity to have part of the engine bay resprayed. So that of course required us to really strip the engine bay out. In particular, the ABS system and all of the ABS brake lines, fuel lines, etc. came out. So another challenge added in there was I wasn't the one who stripped it out, so I was trying to pick up the pieces and figure out where everything went. However, got it all back together, and we kind of got tripped up at the last possible hurdle, which was the fact that we seemed to have an immobilizer fault or an immobilizer problem, and we're not being able to get the car to power up properly. So really frustrating. We sort of pulled the pin on that at about 5 o'clock on Friday night, and missed out on a weekend's racing, but that is life. The good thing with motorsport is there will always be more events, and this will give us a little bit of more of an opportunity to get everything sorted. As with any last minute build, there were a bunch of little tasks that were still left to do on the car, and at best on the weekend we probably wouldn't have had the car finished to a level that we would have been happy with. So this will give us the chance to make sure that everything is completely ticked off and we've got everything how it should be for the next outing. I'm not entirely sure when that's actually going to be, given that we are about to move into winter here in New Zealand, and most of our racing happens over summer. That's okay though, we will get there. Now, I just wanted to also talk, because we have been putting a few photos and stories up on our Instagram, I just wanted to talk about the heat shielding on this particular car. So I'll jump again across to my laptop. This is an Instagram I put out last week, which just shows a picture of our sump here, as well as our heat shielding. On this particular heat shield I've just circled, this protects a couple of plugs for our cam position and a cam actuator for the exhaust cam on this bank of cylinders. And one of the questions we got quite regularly with this post was, what product are we using there? So this is a DEI product. I actually had to do a bit of scratching and figuring out what we had used, given that this setup was built probably about 4 or 5 years ago now. But this is a DEI product, Design Engineering International, I think it is. So it's basically just a adhesive backed film that you can peel off and you can stick on whatever it is that you want to protect. I have noticed in trying to source these gold foil heat protective films that they do vary quite dramatically in price. I have no doubt that they also vary quite dramatically in their effectiveness. I can't say that I've done a bunch of back-to-back testing, but we have found that this particular product does seem to work quite well. And in particular here on the sump, you can see one of the reasons that we did this is because the runners wrap around really close to the sump itself, and of course particularly with a turbocharged header, that header gets very, very hot under sustained wide open throttle, high boost operation, and of course that then transfers heat or radiates heat into the sump, so that puts more heat into the oil. And this is one of those areas where if your oil is getting too hot, particularly if you're not monitoring that and you're not aware of how hot your oil is getting, it's another area where particularly the Subaru engines, the FA20 and the EJ series engines, they don't have very large big end bearings. They are well known for bearing reliability problems, so getting heat out of the oil, making sure that the oil is operating at a temperature where it does offer good lubricating properties, this is one step we can take into making sure that our engine is going to live a long and healthy life. Right, in terms of our other 86, we have got one of the last parts of the puzzle turn up just last week, which is our Motorsport Systems strain gauge gear knob. So this is going to go on top of our TTI sequential 6-speed shifter, and the advantage with using a strain gauge gear knob, or I should say what the strain gauge gear knob allows, is that it sends out a signal. There's a strain gauge and a conditioning circuit inside of this gear knob, and basically it can sense what we're doing in terms of our hand on that gear knob, whether we are pulling back on the gear knob for an upshift or we're pushing forward for a downshift. So what it does is it outputs a voltage to our ECU. In this case, we are running a Motec M150 ECU. We've got a 3-wire harness that comes off this. Basically it takes 12 volts, or I think in this case it actually will take anything from, I think, maybe 6 or 9 through to 16 volts. It's got a sensor ground and then an output, and in the normal position where we're not touching the gear knob, it'll output about 2.5 volts to the ECU. As we pull back on the gear lever, that voltage, I think for an upshift, it drops away towards 0, and basically it is in relation to the amount of force we're applying to the gear knob. So the harder we pull back on the gear knob, the closer to 0 volts that voltage gets, and conversely when we push forward on the shift knob, the voltage increases from 2.5 volts up to 4.5 volts. So this allows the ECU to then distinguish whether we're pulling back on the gear lever or whether we're pushing forward on it. Now why that's important is with a dog engagement gearbox, particularly for the upshift, we don't need to use the clutch for the upshift, and with one of these strain gauge gear knobs we don't need to lift off the throttle. That signal, when we're pulling back on the gear lever, just signals to the ECU that we're requesting an upshift, and then inside of the ECU we can activate the gear change ignition cut. So this could be an ignition cut, it could be a fuel cut, or it could be a combination of both. And this just allows the dogs to disengage so that we can disengage the lower gear and we can engage the higher gear. And this all happens very, very quickly. The shifts may be somewhere in the region of maybe 50 to 80 milliseconds. This is all closed loop as well, so the ECU is actually monitoring the current gear position. So it will apply that cut only as long as it's necessary for the next gear to be deemed active, and then it will reintroduce engine power. So from the driver's perspective, this is all nice and seamless. All we do is stay at full throttle, pull back on the gear lever, and the ECU takes care of the rest. Particularly with a turbocharged car, one of the advantages here is that because we're staying at full throttle and that interruption to engine torque is so momentary, it means that our turbocharger doesn't fall off boost as dramatically as it would if we were lifting off the throttle or we're still using the clutch. Now, with the little Borg-Warner EFR 6758 that we are running on our FA20, that wouldn't make too much of a difference. With large turbochargers, of course, the bigger the turbo, the more this tends to become a problem, and the turbocharger falls further off boost, and it takes some time for it to get back up to full boost. Now, of course, I am using here a turbocharged application as an example. We are running this on a naturally aspirated engine, so we're not going to get the advantage of maintaining boost on a naturally aspirated engine. That should go without saying, but there is still the advantage of that seamless power delivery as we go through the shift. Now, the other aspect with this is because the strain gauge can detect whether we're pushing forward or back, on the downshift with a drive-by-wire throttle equipped engine, it can also provide an auto blip to match revs for the next lowest gear. Now this becomes a bit of a bone of contention. Every time we talk about this aspect, we're inevitably going to get a few people that call us out for technology taking away from the ability or the skill required from the driver, and we're not here to argue that. Definitely it's making the driver's job easier, and the art of a really good quality heel and toe downshift to match revs is definitely something that when you get it right, it's really satisfying. What I would say though is that even after analysing data data from professional race drivers that drive race cars every day for a living, you're going to find that if you're looking at a trace of brake pressure, at the point in the braking cycle where the driver has to swing his heel across and blip the throttle to match revs, you're inevitably, even with a really good quality driver, going to see a reduction in the braking force. So what this means is that it's impossible, even for a really competent driver, to maintain absolute maximum braking while heel and toeing to blip the throttle and match revs. So this sort of system means that the driver can concentrate solely on getting that braking optimized. The ECU is going to do a lot of that hard work for us on the downshift. Whether that's your cup of tea is definitely up to the individual, but of course there is no requirement to use that system. Now, I also wanted to give you an update on our dyno situation. So the dyno that we're currently sitting on, our trusty mainline four-wheel drive dyno, we have had that since we first moved to Queenstown just over 4 years ago now, and it served us incredibly well. And the rolling road type dyno does give some advantages in so much as it is very quick and easy to get the car set up on the dyno, particularly for low powered cars. It's very easy to strap the car down, doesn't require a lot of effort. However, with some bigger horsepower projects in the build for this year, particularly we are looking forward to getting sorry if I get the manufacturer right, the Toyota 2JZ engine that we built for our practical engine building worked example. We're getting that back here in the Subaru WRX that it's fitted to at some point during the year, and we are going to be wiring and tuning that, and we're going to be adding some content around the tuning for high boost turbocharged tuning. I know that's something we get asked about a lot, and this should be projected to be somewhere in the 1200 plus wheel horsepower vicinity. Now that is not outside of the realms of what we can do on a rolling road. However, this particular one, we are only running a single eddy current power absorber per axle line. It's going to be a little bit marginal, and just to give us a little bit more headroom with some future projects, we are swapping across to a Mainline Hub Dyno. So if we just jump across to my laptop screen at the moment, this is something that Mainline have been working on for a while, which is their four-wheel drive version of their Hub Dyno, and they're probably pretty well known for their larger capacity hub dynos. They've been used in drag racing applications for a few years now, and I think the record at the moment is somewhere over 4,000 horsepower at the hubs. Now, we're not going to be anywhere near that, so we need a much smaller hub dyno, and the four-wheel drive system that they have developed, as you can see, those hubs are quite small and they are a little bit more mobile. The bigger Pro Hub 3000, etc., the rear hubs for those are actually physically bolted to the workshop floor. So our mainline dyno that we've currently got, we have confirmed the sale of that. That will be heading offshore in the next 6 weeks or so, and we're looking forward to getting hold of our new hub dyno. As I've said, this will give us the ability to just support some more high horsepower projects, which I know that we have been getting asked about quite a lot. Now, talking about high horsepower, if we just jump across to my laptop screen again for a moment here, the latest release on our YouTube channel is a video that we shot over at TX2K, and this is a Subaru STI built by English Racing, and I think off the top of my head this car has already run into the high 9s on the quarter mile. English Racing are probably better known for their exploits in Mitsubishi Evo racing, but just to show that they aren't limited to just the one brand, they've built this STI. It's producing 1,030 wheel horsepower, and if you want to learn a little bit more about that build, head over and check out that video. While you're there, make sure you subscribe to our channel. And lastly for today, we are just starting out another one of our giveaways. And this time we are giving away a Fueltech FT600 ECU, and this is an ECU that we're pretty excited to actually get some experience with ourselves. It's an ECU that has been getting a lot of traction, particularly in the drag racing market, no pun intended there, and there is a lot of competitors all around the world seeing a lot of success with the Fueltech brand. One of the unique aspects, as you can see here, is that the FT600 ECU actually also doubles doubles as a digital dash or a driver display. It's also touch screen, and this is quite nice because it means that if you want to make some last minute changes while you're in the staging lanes, perhaps to your launch control strategy, maybe there's been a change to the track conditions while you've been waiting for your pass, you can actually make those changes directly from the dash unit. You can do that without the need for a laptop, so it just makes it a little bit easier to make those small changes without needing to run back to the pits hurriedly trying to get hold of your laptop. And we are accompanying that FT600 dash with our suite of tuning courses, so you're going to learn how to actually tune that FT600. You're going to get our EFI tuning fundamentals course, you're going to get our understanding air fuel ratio course, you'll also get our practical standalone tuning course, and you're going to get access to our private online members only forum and webinars so that you can get the most out of that unit. We have only just launched that giveaway, so it's got a little while to run, but make sure you get your name in the draw. There is absolutely no cost to get involved, there's no drawbacks to get your name in there. I'll get the guys to drop a link in the chat that you can follow if you want to do that, and you'll also find that there are a few options you can go through to get yourself some additional entries into that draw, so head along and check that out. Alright guys, thanks for watching. Give us a moment here and we'll get started with today's webinar.